Hey, what's up, guys? This is Chung. So today, what I'd like to talk about is another Codeforces problem. So this one, Boboniu chats with do. Mm, so the description is like this, right? So you're chatting with a person by using this QQ application QQ, and on each day, and a person, this guy called do can chat for n days, and but on each day there is like a fun factor. There's a fun factor AI on each day, and based on the fun factor for the day, so this person can can be muzzled for D days. So the condition is like this. So if the AI is greater than M, then it means that this person cannot chat for like another D days, right? Otherwise, if the current AI is not greater than M, then he can just continue chat on the next day. And it asks you to find the maximum total fun factor, which is basically the sum of the numbers that among all possible permutations. Basically, he can choose like to chat uh, to choose which day to chat first, and then it asks you to find the maximum. So for example, right, we have like this we have 5 days, and the muzzle day is 2 days, and the threshold is 11, and then we have like this kind of factors, and here is giving you the example here. So the person basically he can chat. So this one means that whenever there's like a day that the fun factor is greater than 11, he will be muzzled for 2 days. So that's one of so here's the strategy, right? So this person can chat on 15 uh, with a 15 factor for the first day, then he will be muzzled for 2 days. Okay, and then on the fourth day, right? He will use these 10 factors, but 10 is not since 10 is smaller than 11, so he can continue to chat. And on the last day, he will just use 23 to do the chat, because even though he'll get muzzled for another 2 days, but we only need to calculate the end days. So on the last day, even though it gets muzzled, it doesn't really matter. That's why the total is 48, right? Mm, yeah. So basically, that's the description. The So for this problem, mm, the strategy is greedy. So what do you mean the greedy? So this means okay, let me erase this one first. So basically, there are like two different kind of days, right? So there's a days will get muzzled, right? And there's like days not, right? Get muzzled. So there are like these two different kind of days. And since we're trying to get the maximum, right? The common strategy is that we, of course, will try to always use the use the biggest factor, right? Let's say we have like the factors, and let's say we sort. Let's say we sort the factors. We have 10, we have 20, 19, 18, 17, right? And then we have like a bunch of others like 10, 8, 5, 4, 2, 1, something like this, right? I mean, if the M is big enough, if M is big enough, of course, our strategy will just take the first, sorry, no, so it's uh if the M is big enough, of course we can on each day we can always chat. So the total is gonna be what? Gonna be the total of this kind of array here, right? And but let's say we have some days that will get muzzled, and we're also having some days that will not get muzzled. And since we're always trying to chat from the biggest fun factors going down, right? And so let's say that this first one, if we chat, let's say if the on the first day we chat with this like with a day, sorry, so let me rephrase. So let's say on a day we pick a fun factor that will get muzzled to chat, then it means that we're losing like another D days to chat, right? Mm, yeah. So if we were to choose like a muzzled days to chat, and since we'll get muzzled for D days regardless, so why not just choose the biggest day to chat? Let's say we have like 20, 19, right? 18 and 17. Let's say this all 4 days will get muzzled. Then if we were to choose one muzzle day, so we will of course choose the biggest one, right? Because since we'll get muzzled for D days, why not just choose the days with the biggest factor, with the biggest fun factor, right? And then if we were to choose like 2 days, 2 days that will get muzzled, right? Of course we'll choose the first two biggest number. Yeah, and that's gonna be our basic strategy. Basically, we'll choose the fun fact the days, right, from the biggest number to the smallest number, and um, and if that day is getting muzzled, right, so we will calculate the remaining days. So what does it mean? It means that let's say we have if we decide to choose 2 muzzled days, so how many days will get muzzled? It's not 2 times d. And why is that? Because we can always make move one of the days, right? One of the days to the end of our permutation, so that actually the total uh, days left, the total muzzle day is going to be what? It's going to be let's say uh, we have I minus 1, right? And times a d plus 1, and then we do a plus 1. So let's say I is equal to 2. So this one basically I'm saying that so for so we will move, let's say we have 20 and 19. So on the first day I'll use 19, right? And then the 20, I'll move this 20 to the end of this array here. I'll move 20 here, so that the last one will not be get muzzled for another d days. That's why the total muzzle days will be I minus 1 times d plus 1, right? So this plus 1 means that we're also counting for the current days, including the current day, right? And then this plus 1 means that so the 20, so the last 20, it also counts at 1 day. So yeah, so here it's not actually the muzzle day. It's just like the total days we have used so far. And then if we do a n minus this one here, so we'll get the what? We'll get the days left, right? So basically, so here I'm saying that if I choose 2 muzzle days, right, and then I have this n minus this one days left that I can choose from, because for this one I mean we cannot chat. So for this kind of days left, we will choose from the days that will not get muzzled. And let's say the m is equal to, let's say m is 12. So which means that we can split these days from here, right? So everything that's on the left of m here are the days that will get muzzled, and all the days on the right side that will not get muzzled. So since we have like these days left, and of course our strategy will be choosing the 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 remaining days from the biggest to the smallest. It's also like a greedy approach, right? And yep. So that's going to be our algorithm, greedy algorithm. Basically, we will categorize the days and into the days will get muzzled and the days will not get muzzled, and then we'll try to get we'll try to choose one muzzle day and two, three, four until we have tried all the possible muzzle days. And then for each of the scenarios, we'll calculate the days left based on this kind of formula, and then we'll try to basically fill in the days left with the non-muzzle days from the biggest to the smallest. Okay. Mm, so since we're going to do some like a range sum, right? For example, if we are at like this 18, right? We want to get the total of the muzzle dates for the first 3 days. And similarly for this one, if you want to get if let's say the days left is 4, so which means that we need to get 4 numbers from here to here. So that's gonna be another range sum. So that's why we're gonna do the pre-sum technique so that it can help us improve the performance. And yep, I think that's the idea, and we can start coding now. Okay, cool. So we have what do we have? Hmm. We have like n, d, and m, right? So that's going to be 3 uh, parameters, and we also need like another a, right, to help us to get to store all the values for the day. And so first, let's try to read those value in, right? So we have n, d, and m. And so I'm going to use like another integer. So this one I'm just calling the muzzle days, right? Starting from 0, and I'm using this one to count how many days that will get muzzled. So and then for int I in 1, right? And then I smaller than n, right? And then I plus plus. Then we'll do this I. Then if the AI is greater than m, right? And then we increase the muzzle day by 1. Okay. And then we just need to sort, right? We sort this one from the biggest to the smallest. That's gonna be a plus 1. And yeah, since we're starting from 1, right? Not 0. That's why we do a plus 1, then a plus 1 plus n, and then we have greater uh, ll. Yeah. So that's the sorting part. And then second is next one is we're gonna do a pre-sum, right? So well, I is starting from 2, I is equals smaller than n, I plus plus. We just accumulate, right? So I from a I minus 1. Okay. And yeah, so basically there's like a special case. Let's say if the muzzle day is 0, then we can simply return because it means that we can always chat on each day. So we can simply output the AN, since which is the sum of all the days fun factors, right? And then we can just return. So that's gonna be the special case. Else, let's do a answer equal to 0, right? And then we're going to start picking the muzzle days one by one. So we start from the first day, and then we end with this muzzle days, which means that we will try all the muzzle days. And then I'm going to have like days left, right? So the days left, like I said, we have a n minus what? N minus this I minus 1 times d plus 1 and then minus 1. So this is going to be the days uh, we have, okay? And of course, right? So if the days left has to be greater than 0. So otherwise, and then we would update the answer because otherwise, let's say if we have like we have 20, 19, right? 20, 19, 18, and 17. Let's say the m is equal to 2. So which means that all every day will get muzzled for like 2 days. So once we're at like this 18 here, right? I mean if we use this formula, the days left could be less than 0. Okay, that's why we only going to populate our answer when this one is like is greater than 0. So if it's smaller than 0, it means that we cannot pick we cannot pick this many muzzle days. So for this one, it's going to be what? It's going to be a max of course, max of answer, right? And the answer of what? So like I said, we have like 20, 19, 18, 7. Oh, sorry, it's this one, right? We have like uh, if we are at like this index here, so we have days left, and then we need to find the range from here to here, okay? So which means that it's going to be a range sum, right? A range sum from this location to this location. So what's going to be the value? That's going to be the a dot muzzled day plus days left, right? And then minus the a dot muzzled day. So this is going to be the the sum for the value of the remaining days. But there's like also a small thing we need to be careful. It's this one, the MD plus days left, it could be greater than N. And why is that, right? So let's say we are picking I. So we're at this I is like at the first muzzle day, and then the days left. So the days left could be pretty big, if we have like if the D is equal to 2, okay? And let's say we have a lot of days will get muzzled. Let's say the muzzle date is somewhere here, right? And then it means that, if we use this, if we use the days left and then plus the muzzle days, right? Since the muzzle days is here, it's very close to the end. And if we do this days left plus muzzle days, right? So it could be more than the length of n. more more than the length of the array here. So that's why we need to do a minimum of the MD, this one, and N. Yeah. So this way we can handle all cases, and to make sure we'll get the correct total factors for the non-muzzled days. Hmm. Yeah, and of course, right? Don't forget to add the values for the muzzled days. That's going to be the A of I, since this A stores the total, right? The pre-sum of the current location, and then in the end we simply output this one here, the answer. Uh, yeah, I think that's it. So let's try to run a few examples, right? Mm. So we have 15, and that 15. Uh, yeah, I don't think that's right. So let's see. Uh, oh, here. Yeah. So we don't have another T here. That's why we shouldn't read this first T here. And yeah, let's try it again. Yeah, so this time it's correct. 48, right? And then let's try another one. Try this one, the second one, which is more complicated one. Yeah, 195. Yeah, which is also correct. Yeah, I think this one works. Cool. So yeah, basically that's it, right? I mean for time complexity, it's pretty straightforward. It's like the O of n, right? So we have a pre-processed. Sorry, it's not O of n. Sorry, it's a n log n, because we have a sort. We have sorting here, n log n, and then here it's just like O of n. Yeah. Mm, yeah. So I think that's it for this problem. This one is like the greedy problem. Basically, just to recap, right? We're trying we're categorizing those days into two different groups, and then we try to uh, choose the days in the greedy approach, which means that we always try to choose the highest, the days with the highest factors. But by doing that, we might end up paying a cost, which means that we might get muzzled for like n days. Okay, and for that case, right, we're gonna basically calculate the days that we have been used, and then how many days how many days left that we can still chat, and then with that we can just uh, pick those days that will not get muzzled, and then we'll calculate the final result, and then in the end we just get the maximum among all those kind of scenarios. Mm, cool. I think that's it for this problem, and thank you for watching the video, guys. Stay tuned. See you guys soon. Bye bye.